6, and we are over here on example 4. So our last example here is looking at the possible values for P for the divisor of the constant term. So what that means is that whenever we were factoring, so let me bring it back to a trinomial. Okay, so let me look at a trinomial. If I said to you x squared plus something x plus 12, right? So pretend there's a number there. If I was going to factor that, I would look for what multiplies to 12 and adds to the middle term. So my brackets, when you look at this, I know that that 12 would go here and here. So it's either going to be 1 times 12 or 2 times 6 or 3 times 4, right? So this last number was the key number when I'm talking about the roots. Okay, so that's true. Okay, so we know that that was the number. So if I was saying, okay, the factors would be some multiple of 12. I wouldn't try 7, right? 7 doesn't make sense because it doesn't go into 12, so there's no way it would be a factor. So it was factors of 12. Then what happens is that what happened if I gave you a number in front? That number in front changes it because I have, say, potentially a 5x and an x here. So I would still have the factors of 12 as my last number here. But the first number, it would be some sort of 5 maybe would be hanging around somewhere, right? So a 5 could possibly be hanging around somewhere. So when you look at your roots, I know that my roots would be x could possibly be positive negative 1, maybe a 2, maybe the 3. Does that make sense for the 12? Maybe a 4, maybe a 6, maybe a 12. But this 5 means that it could have been maybe 5x minus 3. Does that make sense? Or 5x minus, say, 2. Or 5x minus 12. Something there. So that 5 means that my x value, when I get my x value, that 5 is the divisor part. Not divisor, the denominator part. So each one of these could have been a combination with the 5 under it. So when you look at the possible factors, right, the possible factors that go into this trinomial, it's combinations of the 12 with the 5 possibly dividing into it. That same theory holds true when it's any polynomial, not just a trinomial. So that works with a trinomial. It also works with a polynomial. If the coefficient here is 1, so that's a 1, then you're only looking at possible factors of 24 that could be a factor of this polynomial. So then for this one, I know that it could possibly be, okay, to divide into this, it could possibly be positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 4, positive or negative, where do I go to? 6, yep, positive or negative, not 7, not 8, not 9, not 10, 12, right? Positive or negative, and we're going to have to jump all the way to, and I kind of match it, 1 to 24, 2 to 12, so I do this, and I go, okay. Sometimes this helps me, I go, so it's 1 to 24, 2 to 12, 3 to 6. Oh, I'm missing one, right? And I go 8, so that's why. So I do this matching game, and I go 8, and then 4 to 6. Right, so I like to match it. That way I know I didn't miss one. So 1, 2, whoops, 1, 2, right? So I go match it, and then that way if I missed one, like 8, then I can fill that in after, right? So I go match it. So positive negative 6, positive negative 8, right? I did that on purpose because it should match 1, 2, 24, 2, 12, 3, 8, 4, 6. Okay, so listing it sometimes doesn't help. I like the matching game, right? So you match it together. So those are all the possibilities that could divide into here. How do I know which one divides in? We're using the factor theorem and the remainder theorem, a little bit of both. So I know that if it's a factor, that ends up being an x-intercept. If it's an x-intercept, I know that the y value should be 0. So then I come back to here and I go, so then that means when I plug in the proper one, the one that works, the y value should be 0. So we're looking for when does it equal 0? F at what equals 0? So try them. I don't need to see each try that you do. So if you're going to try 1, you can actually just punch it right in. So you're going to go 1 to the power of 3 minus 1 squared minus 14 times 1 plus 24. Plug her in, I get 10. Doesn't work, right? I don't, oh wait, no, that one should work, right? No, I get 10. I got 10. So I got 1. So 1 to the power of 3 minus 1 squared minus 14 times 1 plus 24. Yeah, that's definitely 10. So I get 10. I don't need to see the failed attempts, right? You can show me, but then it ends up being like, I don't know how many you'd have to show me, so don't show me, okay? So what I want to see is your first successful attempt at finding a factor. So you don't have to show me the failed ones. You go, okay, I tried it, it didn't work. Then I'm going to try f at -1. I'm going to try -1. I'm going to try, and then make sure you do brackets. So this will be bracket -1 bracket to the power of 3. So make sure you know how to use your brackets. If you don't, or you can do a little bit of mental math. So -1 squared is just going to be 1. So -1, and that'll be plus 14 plus 24. So you can do it like that. I got 36, so it didn't work. 1 and -1 didn't work. So I don't need to see your failed attempts. Show me the first one that worked. So try f at 2. Try f at 2. So it'll be 2 to the 3 minus 2 squared minus 14 times 2 plus 24. 0. Right? I don't need you to show me each substitution. I want you to show me your conclusions. You can skip to this. F at 2 equals 0. So show me that you got the 0 from 2. Therefore, what's my conclusion? That x minus 2 is a factor. Do you have to show me this? No. This is just in your brain. Those are the factors that you're trying. Would I start with 24? Gosh, no. Look at the middle term. There's 1 and a 14. Don't start at this end of this. If these guys were like 140, 120, then I would start at the 24. But see how small those guys are? I start at this end. I start positive -1, positive -2. You can even feel like lucky. You're like, oh, I'm feeling lucky. It's 3. Right? And just start. It's up to you. But keep track of which ones you tried. Right? So you go, okay, I'm not going to try 3 again. I just tried that one. I usually just start at the left and go, okay, positive -1. Some people go with a feeling. They're like, well, I see a bunch of even numbers. I'm going to try an even number. Stuff like that, right? But don't start with 24 because, look, the middle numbers are so small, right? There's no way it was going to be 24 or 12. Okay, so start with something logical. You get this. I want you to show this and go, okay, yep, I got my first factor, and then write that. That's a good habit to get into. I found it. I wrote my factor. So that's a statement. Then at the end, you're going to put it all together because I'm asking you to fully factor it. It's always fully factored, so you're going to put it together. Okay, so then, so I found my first one. After you find your first one, we are now going to divide. You have your option of dividing polynomial division or synthetic. I like synthetic just because it's a little faster. So we're going to do this a bit longer, and we're going to put. Now, what do we put over here? Be careful. We're dragging this over. What do we put over here? If x minus 2 is a factor, it's 2. Good. Okay, be careful because it's the opposite, right? So it's going to be, I found it was 2. X minus 2 is a factor. When you plug it in here, it's 2. Right? So think, process, and then make sure you got the right sign. Then we're going to do coefficient. So I have power of 3, degree 3, 2, 1, nothing. So we're going to go 1, -1, -14, and 24. Space it out so that you're not too scrunchy. Right? Like, so you don't want to be overlapping your numbers, so make it big enough so you can read it. Okay, and remember with synthetic, our theory was we always divide the first by the x, so you drag down the first number. Okay, then you multiply. 2 times 1 goes here, and you add. Multiply and add. Right, so we're going to multiply. I'll just show it on this one. So we multiply it, and then put it there, and you add it. Multiply and then add it here. Okay, you don't have to show what I showed in light blue there. So you're adding it, I get 1. 2 times 1 gets me 2. I add it, I get -12. 2 times -12 gets me -24. I add it, I get 0. Is that a shock? No, because it has to be a factor. Right? Had to be a factor, you should be like, good. If you're like, wow, it's 0, you shouldn't be shocked because you chose it because you said it was based on this, right? The factor theorem that the y-intercept, it is an x-intercept, so the y equals 0, so it should be 0. Okay, so then that means for my answer here, remember, if you're dividing this one by a linear, it's 1 degree less. If that's a power of 3, this is a power of 2. This would be power of 1. This would have no x. So that's what I have left. Can I factor that again? Multiplies to negative 12, adds to 1. Yep, I can. So 4 and a 3. Okay. Then I want you to conclude, put it all together, because right now it's still a bunch of calculations. I want you to put it all together and go, okay, therefore, okay, fully factored would be, take your first factor. The common mistake is that you forget your first factor, which is crazy because you did all that work on your calculator to find it. Please double check, right? So then you're going to do your final answer there. Double check. This has a degree of 1, 2, 3. My original question has a degree of 3. We're good to go. Right? You should know you're wrong if you wrote down only 2, because you'd be like, wait, that's a quadratic? No, it's a 3, so make sure you write down all 3. Yeah?
Couldn't you just find all of the roots by like doing
You,
calculator?
you can. So if you're like, you know what, I love this, you don't need to do the synthetic, go and say 12. What are the multiples of 12? Again, start with 1, 2, 3, all the way up to the 12. And if you had found negative 4 and 3, you didn't have to do synthetic at all, you could just find all 3. Yep, absolutely. Right, so you can use this factor theorem and just find all 3. I'm going to show you what to do, what if it is a fraction, like what if there's a 2 in there in front. Yeah, but here you kind of go 12. Now, what happens though is that sometimes you go through all these, and I'm going to show you one, and this is not factorable. And then you go, oh my gosh, I just tried all those and it's actually not factorable, which just means that your last trinomial. So I'll show you that one. Okay? So once you get there, you can kind of go, you know what, I don't want to do this. I can check, 1, 2, all the way up to 12 and find your other factors. I'm going to try another one with you. So flip over. I'll keep the recording going. And flip over. Let's try that again. So we're finding our first factor. Okay, multiples of the 18. Okay, and again, you can go all the way up, all of them. You don't have to list them. Because I see that 9 and 5 are not too big, I'm not going to start with 18. Right, so positive negative 1 with the positive negative 18. There's a positive negative 2 that matches the positive negative 9, and positive negative 3, which matches my positive negative 6. I'm not starting with 9 and 18, too big. Even 6 is a little intimidating because I'm not sure. So again, I would start at this end. Right, you decide what's easier. Try your first numbers, and you're trying to get your first 0. Your first 0. Right, so if I try it, I go 1. If you can even do the mental math, I'm going to go 1 plus 9 plus 5. That is 15, so I'm not going to try 1. 1 doesn't work. Right, so you can kind of do 1 in your head almost. 1 plus 9 plus 5 minus 18, no. So I'm going to try negative 1, so it'll be negative 1. That'll be plus 9 minus 5 minus 18, so I'm doing a little bit of mental math. Negative 15, so negative 1 doesn't work. And I'm going to go on to 2, right? So 2 to the power of 3 plus 9 times, and you can do a bit of mental math, so times 4 plus 5 times 2, so 10 minus 18, 36. Right, so it's too big, and then I'm going to try negative 2. Sometimes the negative will bring it down, because look, see how the plus is? Some people go, you know what, I didn't try the plus because I saw it was a plus 9 and a plus 5, so I tried the negative first. So when you start these, you kind of go, oh, wait, I might try with the negative first because I see so many pluses. So you kind of get a bit of a feeling sometimes. So I'm going to try bracket negative 2 to the 3. So make sure you put the bracket plus 9 times, and you want the bracket, or just do 4. So negative 2 like that squared. I can do the mental math, so 5 times negative 2, so minus 10 minus 18, 0. Okay, and that's why some people go, oh, I saw the pluses, I didn't even try the negative, I didn't try the positive first, I tried the negative first. And look, so negative 2 works. All right, so then you're going to tell me which one you found was first. So I'm going to say F at negative 2 worked for me, and I got 0. And you can try it one more time. Sometimes you go, okay, I'm going to just try it one more time to make sure I punched it in right, but you got your 0. Then I go, therefore, x plus 2 is a factor. Okay, again, you don't have to show this. This is just my brain thinking. Then you can use synthetic to divide in, or you can look for molar multiples of the 18. Now, what I would recommend, though, is try synthetic to see what you get left over, because look what happens with this one. So this is why I was showing you this one, because, yep, you can use this method, but when you drag this one here, okay, the number that goes there is -2. And we're going to go power of 3, power of 2, power of 1, nothing. So it's 1, 9, 5, -18. Okay, so drag down the 1. -2 times 1, multiply, put it here, -2, and then add it. So 7, multiply here, -14. Okay, add it, -9. Multiply, it's 18, add it, 0, which should not shock us because it's a factor. So you can try it again, multiples of 9, and then try to do this again, but I purposely gave you this case. So look, it's 1 degree less, so x squared, 7x minus 9. What happens when you try to factor that again?
Can't be factored.
Nothing, right? So you could try all of these. So this is kind of a brute force. If you're a computer, no problem. Good, right? Because it's a cycle. You just program, input each number. When it gets to 0, let me know. It would go bing, 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 done. So program that in. It's super fast. As a human, that would take you a long time. So synthetic would be better to check to see if the next one even looks possibly factorable. Right? So don't just try to do all of these. It does work, but also you would have to go through all the possibilities to know it doesn't factor. So do the synthetic. You can see multiplies to 9, adds to 7. There's no possible way. So then stop, and then you're going to go therefore. It's going to be x plus 2, and then x squared plus 7x minus 9, all done. You can't factor anymore. If you can't, you can't. Can't force it. Is that a degree 3? Yes, it is. We're good. Okay, so just make sure your answer matches the beginning of the question. Questions with that?